Okay, we'll try to kill two birds with one stone here. So, you could be asked to, for instance, suppose you're told f of x equals x squared, and, it says something like, find the derivative using the definition. Okay, so using the definition. Okay, so the reason I'm kind of killing two birds with one stone is that this involves a limit. So we can, you can also talk about, well, we have technology. How could you find the limit? And now, in this case, we're gonna see that Desmos in this general case doesn't actually do much for us anyway. But so, right, I want that derivative. So I know f prime of x, or df dx, is df of x dx is the limit as h goes to 0 of f of x plus h minus f of x over h. And so that's the limit as h goes to 0 of x plus h quantity squared minus x squared over h. And now I have to multiply things out. So I get x squared plus 2xh plus h squared minus x squared over h. And so we have the limit as h goes to 0 of our 2xh plus h squared over h. And this is the limit as h goes to 0 of h over h times the limit as h goes to 0 of 2x plus h. And at this point, right, we know that this thing's 1, and then I can do direct substitution, get the 0 in there for h, so I get 2x. So again, if you're asked to do this sort of problem or do a limit where you need to do some algebra and some cancellation and so forth, you need to show that. Okay, you need to show these steps in here so we know you know what you're talking about. But again, you can try to check your answer with the technology. So we got 2x, and if we go here to Desmos, well, I typed in the x plus h quantity squared minus x squared over h. I call it f of x. You can call it whatever you want. And I made h into a slider, and then I changed the bounds between minus 0.5 and 0.5. And I can sort of do this. Well, you see, I'm looking at the graph, so it really didn't do much for me. Okay, so that, not so much. We'll come back to this, but for a general problem like that, Desmos isn't really going to help me anyway. But on the other hand, if I go here and I say, well, I want to declare two symbolic variables, x and h, and I say f equals x plus h quantity squared minus x squared all divided by h, and then I say take the limit of f as h goes to 0, but you do it by saying it with h equals 0 and then show that that limit, 2x. There it is. Okay, so I can check my answer, but if all I see is 2x, no, that is not showing me you understand the idea of the limit, the definition of derivative, and those kinds of things. So, I would want to see that. But again, you are more than welcome to come to SageCell and check your answer. Now, with that, let's go back, and in this case, if I, Desmos could be helpful if instead, it asks for, you use the definition to find f prime of 2, something like that. Well, so we know we should get the answer 4 because it's 2 times x. But if you're using the definition, right, you'd say f prime of 2 is f of 2 plus h minus f of 2, over h. Oops, limit, forgot my limit, as h goes to 0. And so we have our limit as h goes to 0 of 2 plus h squared minus 2 squared over h, dot, 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 right? And you'll have the limit as h goes to 0 of your h over h, which you had before, and then the limit as h goes to 0 of 4 plus h. Okay, and you'll be able to, again, 1, and you'll get your 4. Okay, so I did the dot, dot, dot because we did it up here. You don't get to do dot, dot, dot on an exam. Okay, so, though, if it were 2, well then actually, Desmos can help there, because what I could do is, I could look at here at f of 2, so I'll have to type it in now, and I could start it out with the definition as we had it, but since I already have this, so f is that derivative, I can do f of 2, see, and it's 4.4, and Desmos could be, helpful this way in that, I could watch that number and see that as I bring this down, it looks like it's heading to 4. See, right at 4 it was undefined, but I could see, numerically it appears that it is going to 4. Or another way to make this happen is my f of x, I could actually change the h's to x's. And so that again, I could, whoops, that, so make that an x, and down here an x, and then my x's, that's where I had the 2, so I could have a 2, and a 2, so I could do that and look at the graph, so these don't matter anymore, make my h into an x. Now I think I could use f of h, and use an h in here and so forth. It's just a lot safer, I find, to use x's when you're doing it. But then, I can look here at where my h or x equals 0 right here. And, if I do that, it, oh, it'll probably be undefined there, right? Yeah, undefined. But again, I can look at it and see that it appears to be going through 4. So I'm probably right, getting an answer of 4. And then, of course, with Sage Cell, everywhere I have the x, I could put in the 2 and do the limit, and it should come out to 4. If I can get that in the right spot, backspace, make that a 2. Backspace, make that a 2. And then evaluate and I should get 4. And there we go. Okay, so I can check my work, but in something like this where, you know, it's asking you to do things like the textbook has done, you know, show this or just determine this. We want to see some actual mathematical justification, not just an answer with the technology. Now, and again, the algebra part here, if you want to put that into Sage Cell to make sure that you have squared that out correctly, great. Okay, I'm fine with that. You know, you can do the algebra there. I want to see calculus. I want to see this idea of the definition of the derivative. I want to see how you work limits. Okay, I want to see that you know the calculus. All right, so that does it for kind of what you might do with limits or say a definition of a derivative.